Everyone. So I want to look at the idea of colligative properties and specifically how we can use the lowering of vapor pressure to determine the molar mass of a substance. So in this question, we're looking at if you have the vapor pressure of pure carbon tetrachloride and you add a non-pure, non-volatile substance and it lowers the vapor pressure of the carbon tetrachloride. So hence you can see the two vapor pressures are different and the vapor pressure of that solution is lower. Then it asks you to calculate the molar mass of the solute. So let's get some perspective and first draw what's going on. So initially you have your pure solvent, so CCl4. It has a vapor pressure, right? And it's the vapor pressure of the pure solvent, CCl4. And that's given as 0.437 atmosphere. You're also given that it is we have the mass of CCl4. There's 100 gram of it. We're then told, right, to this we add 7.42 gram of what? Of a solute. So maybe let's actually give it a name. We say the mass of solute added is equal to 7.42 gram. All right, and that then creates a solution over which the vapor pressure, so let's give the solute, so you see there's a solute dissolved in the liquid, over which the vapor pressure changes, right? And the vapor pressure of the CCl4 over this solution is 0.411 atmosphere ATM. Okay, so that's what we know. That's what we're given. Then we're asked, what is the molar mass of this solute? What is a molar mass? Well, a molar mass is a gram per mole expression. So that means we need the mass of our solute, and we also need the number of mole of our solute. We have the mass. Mass is 7.42. So that means the only thing that we need to determine actually is the number of mole of our solute. So how can we use the given information to determine the number of mole of the solute? Well, hopefully you've deduced from the question, vapor pressure lowering has to do with Raoult's law. And Raoult's law gives us a way to determine the number of mole of the solute. But we have to think first what Raoult's law gives us. Raoult's law says something about the vapor pressure of the solvent over the solution is equal to the vapor pressure of the pure solvent, or maybe it actually says the mole fraction of the solvent multiplied by the vapor pressure of the pure solvent. All right, and if we write that in terms of what our situation is here, that means it's the vapor pressure of this carbon tetrachloride over the solution equals the mole fraction of carbon tetrachloride multiplied by the vapor pressure of pure carbon tetrachloride. Okay. And which quantity in here is going to help us determine the number of mole of the solute? Well, if you think about it, it's the mole fraction, because the mole fraction, XCCl4, is going to be the number of mole of CCl4 divided by NCCl4 plus the number of mole of the solute. So we can solve this for the number of mole of the solute. All right, So what we need to do is we can determine the mole fraction from Rahul's law, and then from the mole fraction we can determine the number of mole of the solute, and then from that we can determine the molar mass. All right, so let's get an expression first for the number of mole of the solute. So what is N solute? So let's go here. NCCl4 is equal to NCCl4 divided by NCCl4 plus N solute. And that means that mole fraction is multiplied by NCCl4. You can of course calculate these things directly, or some of them you can calculate directly. So you can calculate the mole fraction and then solve this. But I like to do things symbolically. So then you get this expression. Now we want to solve for N solute. So this means that we will get XCCl4 NCCl4 plus XCCl4 N solute is equal to NCCl4. Okay. And then we get N solute on its own. So N solute is equal to NCCl4 minus XCCl4 NCCl4 divided by XCCl4. And you can take that a step further, say take out the NCCl4 as common value, 1 minus XCCl4 divided by XCCl4. All right. Question is, what is XCCl4? We can get it here from Rahul's law. So XCCl4 is equal to PCCl4, so the vapor pressure of the solution of carbon tetrachloride over the solution divided by the vapor pressure of the pure carbon tetrachloride. So we can go and substitute that in. And that means NCCl4 multiplied by 1 minus PCCl4 divided by P naught CCl4 divided by PCCl4 divided by P naught CCl4. So once again, you can calculate this separately and plug it in, but now we have a full expression for N solute that we can substitute in wherever we want. So now we can just plug in all our values. Things that we need. What is the number of mole of NCCl4? So we can calculate this. It's going to be, of course, the mass of NCCl4. So it's 100.0 gram multiplied by divided by the molar mass in principle. So there's 1 mole of CCl4 weighs 153.82 gram. And this will give you a value of 0.650 mole CCl4. Okay, this you can plug in here. So this means we have 0.650 mole CCl4. This is 1 minus the vapor pressure of CCl4 over the solution is 0.411 atmosphere. The vapor pressure of our solution here, PCCl4, is 430.437 atmosphere. And then this is divided by this thing again. So that's 0.411 atmosphere divided by 0.437 atmosphere. Okay. All right. So this thing should give you a value of 0.0411 mole solute. All right. I don't hope I made any mistakes. So you can just perhaps check my value there at the end. Okay, so then the last thing that we need to do is we need to take to get the molar mass, to say molar mass of the solute is 7.42 gram divided by 0.0411, etc. mole. That's going to give us 180.42, etc., which you can round to 180 gram per mole. Okay, and that's the molar mass of the solute. Good. We can quickly just run it. The basic point of this is you need to determine, you're given the mass, you want to get the molar mass, so that means you need a mass divided by a number of mole. To get the number of mole, the only quantity that you can relate is, of course, this mole fraction, and this mole fraction you can relate through Raoult's law. So that is what you eventually then you grind through some algebra, or you can calculate quantities on your own. So like you can immediately calculate this mole fraction here by going to say 0.411 divided by 0.437. That will give you, I think that is 0.94, etc. So then you can immediately substitute that in here. You can also substitute in the value of the number of mole of this, and then you can calculate the number of mole of the solute directly if you would like to do that. You don't have to be as intense, let's call it, as I necessarily do things. And I just like to, sometimes I like to be difficult, right? So that's how I do it. Anyway, cool. So you guys should get the same answer. This is eventually what you get. And then you get the number of mole of your solute, and then there you go. All right. So that's it for this question. And in general, for your colligative properties, that is how you can get the molar mass. So remember, molar mass determination, get the mass of whatever your solute is divided by the number of mole. And you just need to identify where you will get the number of mole from. All right. Thank you for watching, and I'll see you in the next one.